So in our previous video, we were able to set up the player spaceship here to move left and right and up and down. But as you can see, the player can actually leave the playable area, and we want to be able to keep this player inside this playable area and also clean up some of our code from last time. The first thing I want to do is double check that in your game tab here, if you're on your scene tab, go ahead and visit your game tab and verify that here that you've changed this to full HD. It's just a standard practice that I do. There are other screen resolutions for different game applications, but I always prefer just to go right to full HD and keep it in that bounding area that the game will actually be played in. And then let's go ahead and double click on your scripting file to go ahead and open that up. So previously we put everything inside this update method. We grabbed the input for the horizontal and the vertical, and then we also created a speed variable that we can use to move the spaceship around the scene in the right and upward direction. Mainly that would be positive, and then the input would then turn negative to put these in the downward or left direction. Whenever you're creating variables, these are called local variables. These variables are only accessible here in the update. So let's say, for instance, I wanted to use one of these variables somewhere else in my program. Just as an example, we'll use the start method. And let's just say I want to set the speed to say 100. Here, I'm going to get this error where it cannot resolve or it cannot find this variable because it's located inside the update method. This is, again, local only to the update method. We want to be able to have variables that we want to use throughout the class as member variables, and we declare them at the very top here just after this first opening bracket. So I'm going to go ahead and take this float of speed here. I'm going to go ahead and cut this out, and I'm going to place this up here. But in practice, I always prefer to write the word private in front of the variables that are private, even though if you neglect the word private, it's by default, it's going to be private. Like these void starts are private, and the void update is private, and these two floats here will be considered private. But just to get in the habit until you realize that, sometimes it's best to just put the word private in front of the declaration of that variable, and then go ahead and provide yourself with a default value, because if you don't, it's going to default back to 0 for numbers or in floating values, and then you have to do this and assign it in the inspector. And then same thing here as well. This X and Y, even though we have these and we're using them here, it's good practice to actually create them up here as well. So I'm going to create a private float for the X. And then one for the Y. Now, because I created them here as member class variables, and they're also created here, these are two different variables. That's why there's no red text for this variable, because these are two, even though the names are the same, they're actually two different variables. So in order for us to fix this, I'm going to have to remove the word float here, because this is the declaration of the variable, and this is us assigning the variable. Now, why won't I put a value here? Where I put speed as having a value, why shouldn't I add a value to the X and the Y axis? The reason is that by default, they're going to be 0. So instead of knowing that they're going to be 0, it's kind of redundant to put the value of 0 here even though the value will eventually be 0. And eventually the number will only go from 0 to 1 or 0 to -1. So again, it's kind of doesn't make sense why I would assign one and not the other, but ultimately I want to make sure that this speed variable has a value at the very beginning, but these ones, they will always be 0 by default. So there's no reason to add that value there unless you want to just be consistent. Then you would then put this in as 0, so that way you have those set up right away. But again, this is going to be one extra step that you don't need. And again, you really don't need to sign this. You can sign this in the inspector as well if we serialize. But currently right now, this is private. I would have to make this public in order for this to show up. So for instance, as an example, if I make this public, or actually first we'll leave it as private. I'm going to save my scripting file, go back to Unity, and back on our spaceship. Once this finishes compiling, that here on the spaceship, there is no declaration of a variable here. But as soon as I write the word public and save my file and back to Unity, let this recompile, and there is my speed variable. Now I'm able to modify the value of this variable here in the inspector. That's one way to access that information. The other way is to, if you wanted to, you keep variables private because you don't want to modify them indirectly. You could create these as a serialized field, which we'll cover later on. But we have our speed. So I've got this set up here as well. We want to verify whenever you make any changes, we want to verify that things are still working in your game. So go ahead and play test, verify that the object is still moving like it should, and it is. But how are we going to keep this spaceship bound into this area? The first simple approach is to determine how far this object moves in each direction and up and down as a boundary. So if I go to my scene, if I'm in my scene, I can't actually see the playable area, but if I'm in my game view, I can see where that limit is based on this blue background, and you can actually modify the values here of your object while it's selected. So I'm going to go to the right. So I'm going to put my cursor up next to the X on the position, and you can see where it goes from the pointer to an arrow side to side, and I can click and hold, and I can drag, and I can move my spaceship over to the edge. So I'm going to go, so that's 8.1. If I just put 8, that's a good boundary. You want to leave a little bit of room so you're not all the way up next to the edge. So going to the right, that'll be an 8 positive, and going to the left, that'll be 8 negative. So let's go ahead and go into our scripting file. Let's make a boundary. So private, this will be a float, and we can go X bounds, and that's going to be 8F. That was our boundary on the X and Y. We'll leave it as positive. We can change this to a negative in through a statement to modify this. And then let's look at what's the up and down. So I'm going to grab the Y, and I'm going to move this up on the Y, and I'm going to go about 4. 4 looks like a good boundary. I've got a little bit of space here at the top for 4 as my Y. Let's go back to our scripting file. And we'll do a Y bounds of 4. Now, where am I going to use these two boundaries? We're going to use these inside here to keep the player inside of that particular area. So this will be an introduction to our first conditional type of statement here. So I'm going to say the word if, followed by an open and close curly brackets. I'm going to look for the boundary or the object's transform position. So I'm first going to check for the transform dot position on the x value. So I'm going to go left and right. And let's say if that x bounds here, as this example, it says a negative x bounds. This is referring to that this variable x bounds has a positive 8 currently. And if I look down here, when you put the minus sign in front of it, it takes the value and applies a minus sign. So now this is negative 8. So we're checking to see if the transform position on your x, if it's less than the negative x bounds, we want to make sure we're keeping that particular object at that position. So what we're going to do is we're going to take the actual transform position and we're going to apply a new vector 2. So we're going to assign, and we're going to say, hey, game, we want to make sure that, and this would be a negative, because this is a negative here. We want to keep ourselves at a negative. So we want to stay at that boundary line, but we also want to keep whatever the current y position, don't modify that. We don't want to modify, because if you're moving up, but you're moving all the way to the left, you want to be able to keep that y position. So we're going to reassign a brand new x and y coordinate for our position in the world if we've reached our outer bounds to the left-hand side. And then we're going to do the same thing going in the opposite direction. So if the transform.position.x is greater than your x bounds, then we are going to modify this and move the spaceship in the positive direction. So I'm going to save my work. I'm going to go back to Unity to verify this left and right only. Currently my player is way over here in the corner. I'm going to set this back to 0 and back to 0. Save my changes, and I'll go ahead and play test. And so currently up and down, I can still leave the actual playable area because we've not told it to stay within bounds. But here, if I go all the way to the right and I'm holding the D key or the right arrow key, I can no longer go beyond that stopping point. Similarly, we can go over here and all the way to the left. So now I've ran into that boundary line where I can no longer go beyond the playable area. And then we're going to go ahead and modify that for the up and down of the Y position. So this will be the same setup, except for we're going to modify and we're going to check on the transform position Y value based on the Y bounds here of our 4. So if the transform position on the positive Y, now you can keep these in any order that you like. So first we went left and then we went right. Here we're going to go up, which is positive Y bounds, where the opposite here is true, where if we're checking for the X bounds, we want to make sure we stay at the X bounds. We don't want to modify the Y position. The opposite here, if you're going to check for the Y bounds, you don't want to modify that X value here as well. And then lastly, we're going to check for that if the transform dot position on the Y, and this is going to be a negative Y bounds, that new transform dot position is going to be a negative Y. Now, if you notice that as I was typing, the IntelliSense from my IDE from JetBrains here is actually thinking about what we're writing code base wise, and it's going to fill in its best idea of what would be the correct output to help save yourself time with writing your code. But you always want to verify if the IDE gives you suggestions, make sure that the suggestion it gave you was correct. So here I'm going to go ahead and save this just to verify this is all set up correctly. Back into Unity, and I'm going to go back to playtest. I'm going to verify again. I can still go left and right, but I'm still stuck within the boundary line, left and right. And now if I go up, I'm stuck across the top there. Similar going down, I cannot go out of this bounds on the up and down. So there we go. We've modified our code. We've kept our spaceship inside and bound to the actual playable area. Next time, we're going to set this player up, the spaceship, and go ahead and start learning how to fire its laser shots. Thanks for watching.